Hey, hello everyone. Today the section is about Longhorn. So I want to talk about Longhorn current and future. I'm David Cole, Senior Engineering Manager of ECP E&I at SUSECON. And this is today's agenda. I will walk through each items, what's a Longhorn, and talk about the relationship between Longhorn and other services, like Longhorn and Kubernetes, Longhorn and Ranger, Longhorn and Harvest. And also, I will dive into Longhorn architecture to understand how Longhorn works and summarize Longhorn current status and what we plan for the future. So, and yet, just let me introduce myself a little bit. I'm Senior Engineer Manager, like I described before, and majorly focus on the container solution and project and product. Longhorn is one of project I'm responsible, and I also attach the links for my personal information, the LinkedIn profile, and GitHub page. So if you're interested in my background, you can take a look. And anything you interested in what we are working on, and reach out to me, contact me, feel free. So what's a Longhorn? Longhorn is the cloud native storage solution for Kubernetes, and it is 100% open source project, and we donate to CNCF.org. And actually, it's built on Kubernetes and built for Kubernetes. It's the solution designed for Kubernetes, support the Kubernetes different workloads. And it is a CNCF sandbox project, but right now we also moving forward to make it move to the incubating project as well. And for Longhorn, the design concept is we want to have a reactive storage service and solution for any kind of workload that leverage Longhorn as their storage provider. So we try to provide resilient, responsive, and highly available, scalable, persistent volume storage for any certified Kubernetes distro, Kubernetes cluster. And the other point for Longhorn, we want to be an agnostic storage service, storage provider based on Longhorn to run anywhere, even from on-premium, private cloud, and edge. So this is why Longhorn, the recent release, we support ARM64 to cover the edge deployment. So this is a Longhorn. So let's talk about the Longhorn history. Uh, Actually, from the 2014, it's a closed source, written in C++. But along the time, with cloud native and Kubernetes adoption, we try to reinvent it and re-implement, rewrite in the Go language. But at that time, still built for Docker. But from 2018, 19, and 20, we try to cover the complete volume operation to work with Kubernetes workload closely and to fulfill all the functionality to support the Kubernetes workload. And not just that, beyond that, we also want to provide a complete volume lifecycle, including snapshot, backup, and even user can set up the backup store outside. We can export the backup to the external backup storage. So this is why we support NFS, S3 compatible interface, backup target, backup store, so you can export your backup. And also we think about how to cover disaster recovery storage support in Longhorn. So this is why disaster recovery volume feature happens. So that means you can restore your backup from one cluster across different clusters to make it like active support, active service for your workload plus volume. And also we try to enhance Longhorn for the volume operation performance. So we increase the performance for the volume detaching. So he make the attachment detachment much efficient than before. And start from Longhorn 1.0, this is a major milestone for Longhorn. We align with the CSI spec to fulfill the CSI spec to work well with the Kubernetes component like kubelet. So we support like volume resizing, volume snapshot, all the stuff you can walk through the CSI interface to operate this kind of functionalities. And also we think about how to cover the different kind of case for recover faulted volume. Because in the Kubernetes, a spatial container orchestration environment, sometimes no down, sometimes no up, sometimes out of resource, sometimes you need to save your cost. So if you have bandwidth for that, so we need to judge, have a better, smart Longhorn control plane to leverage correct resource and react to the different kind of interruption, like a network or system level interrupt, to recover the volume to healthy status. And right now, the latest version is Longhorn 1.1.1 and start from 1.1.0 we support the rewrite many support. And 1.1.1 will also have advanced failure recovery for Longhorn. And not just that, I will share more for some advanced integration from 1.1.1. So this is the short journey for Longhorn history. So if I need to sum up what makes Longhorn outstanding, simply said, he's cloud native. You can run anywhere. It's a scalable architecture based on microservice to make sure we can support adopt a reactive pattern. And also, like I said, reactive pattern is make sure we have a resilient behavior operation when you work with Longhorn with Kubernetes. And we provide a simple and a very straightforward installation solution. So here you can just one click to install Longhorn, and also have a different kind of installation solution. Like you can install from the Rancher catalog or Helm chart, even kubectl manifest directly. And we have a polished user interface, a user experience with our built-in UI. The UI is quite simple, but the simple does not mean simplicity. The simple means it can let the user in short path to get what you want. And like I say, it's because simple, so it's easy to use, understand, and maintain. We don't have many specific terminology you need to learn. We basically will align and based on the Kubernetes knowledge, so you don't need to learn too much to understand Longhorn. And we also provide a complete storage management lifecycle, not just volume management itself. We also provide a snapshot, backup, export backup, and even more about the beyond the volume operation. And the other one, a special from the 1.1.1, we start to extend the Longhorn enhancement to different area, different domains. One of the domain what we focus on is the virtualization storage native support. So for 1.1.1, we can support the virtualization, the VM volume natively integrate with the Longhorn. So we can have a better solution, provide the volume support for the VM workload. And for sure, Longhorn is a large and fast-growing community, and we have the community keep growing, and we have a monthly meetup to share the Longhorn project status to the community users. And users are very active at Longhorn. They always provide some feedback to us, especially in 1.1.1. Many feature ideas or feedback come from the community. So this is Longhorn, how we make the Longhorn outstanding. Next, let's talk about Longhorn community. So how big is the Longhorn community right now? Right now is we have more than 100 contributors from more than about 20 companies contribute to Longhorn. We got the 2,600 stars from GitHub. And in our stat channel, especially CNCF channel, we have more than 1,000 members active there. And also we have a metric system to collect some anonymous information to know how many nodes actually running Longhorn. Until now, about 26,000 nodes installed Longhorn. It's quite a big number. And actually, the reality in the past 6 months, we got a 60% increase. This is very huge and a good result for Longhorn project. So we will keep going to make Longhorn attract more the community that help us to move forward. So we talk about what's a Longhorn, but how about Longhorn work with other service, work with other solutions? Let's talk about the first class service, Kubernetes. So what's the relation between the Longhorn and Kubernetes? If you look at from the Kubernetes side, Kubernetes provide different kind of workload support and management, like deployment, staff set, daemon set, job, cron job, etc. And for the workload, actually, what the things they use in the workload is resource. So resource management and resource access is important, is a mandatory for the workload, including compute, network, storage, and even extensible resource. But how to make it work to communicate with the resource? So this is why the standard interface come out. So for Kubernetes, it leverages CRI, Container Runtime Interface, and Container Network Interface, Container Storage Interface. So different vendor, different open source can conform to this kind of a standard interface to provide their service. So this is the major interface where Longhorn exists and support in Kubernetes. So if you look from the Longhorn have a node because it need volume. So every node it need have a volume management on top of that by Longhorn control plane. And also, if you need to volume to attach and access, you definitely have a database support. So this is support by Longhorn data plane. And for every workload, need to work with Longhorn and attach use the Longhorn volume provided by Longhorn, created by Longhorn. We need to leverage the standard interface I mentioned before, CSI. So we can make sure volume management and access work perfectly with the Kubernetes component like kubelet through the Longhorn CSI node plugin. So this is the major relationship between Longhorn and Kubernetes. But how about Ranger? Longhorn and Ranger. What's the relationship between Longhorn and Ranger? Talk about Ranger. Ranger is an enterprise platform for manage Kubernetes everywhere. Basically, he's multiple cluster and project management for the isolation and multiple cluster. You can manage different cluster on different info. And also you can deploy the application across the cluster. So that means if any downstream major cluster by Ranger, you can deploy like a Longhorn to the downstream cluster and manage Longhorn system lifecycle. And you also have some extended functions like monitoring, alerting, logging, even pipeline, parsing, management, etc. But for Longhorn need to what's the relationship with the Ranger? So for Ranger, you can install the Ranger catalog. You can install Longhorn from the Ranger catalog, like I say. Not just install, including upgrade, uninstall the life cycle. This is quite important because Longhorn have a periodical release. So it's a better way to let user have a low cost to manage their Longhorn system. And also Long have a built-in, have provide a built-in matrix template, promises template can you leverage. So basically, if you work on the Ranger to manage Longhorn, you can based on Ranger monitoring system. So you can monitor the volume usage, node usage, disk usage of nodes, Longhorn manager status, Longhorn instance manager, like Rapid Engine and Replica status. So this is how Longhorn can work with Ranger, and Ranger can manage Longhorn. But how about another topic, Longhorn and Harvester? What's the relationship between Longhorn and Harvester? Like I say, in the latest release Longhorn 1.1.1, we try to support a different functionality for the virtualization workload. So let's talk about the Harvester. Basically, Harvester is an open source project focused on hyperconverged infra solution for the cloud native world. So you not in Kubernetes natively you can manage or do the container orchestration. But from Harvest, it based on the keyword and modules and Longhorn. So you can manage your virtualization workload by Kubernetes way, Kubernetes user experience. And even more, you can, in the near future, you can, in a hybrid environment, to orchestrate container and VM together. So this is Harvest. So what's a Longhorn plays a role with Harvest? Longhorn is the major fundamental for the storage provider, volume provider for Harvester. So what we provide, we can that VM live migration happen because Longhorn will support a migratable volume. So to make sure the VM workload move from node A to node B, but volume can be smoothly to reuse by the new virtual VM workload. And we also support the volume backing image. So that means you can have specified a backing image to populate the created volume directly. So you don't need to really rely on the original process supported by CDI, Kubernetes CDI. But you can leverage that for sure. But you will save your time and get some performance for your volume creation. And how about VM backup restore? Definitely need to support by volume, right? So you can leverage the Longhorn built-in backup restore, even snapshot for this functionality. So this is a relationship between Longhorn and Harvester. So we already talked about what's a Longhorn and different solution, different service solution, the relationship with Longhorn. Let's talk about Longhorn architecture. Longhorn architecture is very designed for the reactive pattern. So measuring around volume, engine, and replica. So let me talk about this one. The first one I want to talk about is the Longhorn Manager. Longhorn Manager is a daemon set deployment. So you will run it on every node, be a Longhorn control plane. The control plane concept, it will respond for volume, all the functionality provided by Longhorn, including volume operation or backup snapshot operation, etc. So also it adapts the Kubernetes design pattern like controller and customer's resource. And for how to work with Kubernetes, like I introduced the relationship between Longhorn and Kubernetes. We need to have implement the standard interface CSI for the controller and the node plugin, so it can smoothly work with the Kubernetes component kubelet for the volume operation. And how about the volume, how it map? Actually, each volume mapped to one of item, Longhorn item, is Longhorn Engine. But Longhorn Engine actually managed in the Longhorn Engine Instance Manager. So here, they have a different type of instance manager, one for engine, one for replica. But each engine actually has many engine process inside, and each engine process actually map it to a one volume, persistent volume. So for replica, actually one engine maybe have one replica or more. So you will have some relationship between that, in between. But actually replica will start or create a manage in replica instance manager. So this is instance manager. And how about a share manager? Actually, Longhorn from 1.1.0 will not just support read-write only block device. We also support read-write many file system storage service for the workload. So how can we do that? We create a new component called Share Manager. It's on top of a Longhorn block device and provide the RWX service for the workload. So that means for Longhorn, you can use a read-write only, but you can also use a read-write manual. So this is Longhorn Share Manager. And talk about Longhorn Engine. Longhorn Engine, so like I say, each engine map it to a volume. Each volume actually map it to an engine, vice versa. So Longhorn Engine actually responsible for volume operation, including attach volume, detach, expand, snapshot, backup, and revert. And also, you need to manage the relationship with its direct replicas. So like a replica, create replica, delete, update, get a matrix of replica, even rebuild a replica. So what's a Longhorn replica? Replica is actually data where the data located. So each engine will have one or more replicas, depends on the user settings. So actually, it respects like your volume operation happen in engine, you will dedicate to the corresponding replica. So like create, delete, open, close, reload, reverse, snapshot, expand. The behavior very similar with the engine because some of operation is dedicated from engine to replica. And also the other part, you need to understand how much disk manage on each node. So when you have a replica on the node, depends on how many disk you are available. They are available to use. And replica not just independent, it still need to handle the communication between the different replicas across the different replicas. Because like the one replica arrows, and after some times you need to review your replica, you will get the correct and clone the correct replica, healthy replica from different replica of the engine. So this is what the communication need for the replicas. And also you need to communicate, you not just communicate inside, you also need to communicate outside. So like you have a backup, you have a snapshot, then backup, you want to export your backup to outside. So you need to go through the functionality, the flow will go through the replica. So this is engine and replica, the real data for the volume. Okay, so this diagram is just summarize what I described. From top to down, you can see each part have a persistent volume, and the volume actually map it to an engine. An engine actually has one or many replicas, and each replica will be located to one node to use the one of disk uh, to save its data. We also leverage each node CPU and memory to have some control to make sure engine instance manager and replica instance manager make sure they work well. And even have some failure happens, like one replica fail, the engine can directly reach connected to another healthy replica to make sure the volume is still working without any issue. But if how about the volume detached and any interaction for the volume happening, so the engine can be relaunched to another load to attach to the new launch, new start workload to connect to the original healthy replicas. So this is why the Longhorn and Longhorn adapted this kind of reactive pattern to make sure that all the engine, replica, and even body functionality work as expected. So this is Longhorn architecture. So we talk about what's a Longhorn and the relationship with the different service solutions, and also dive into understand the Longhorn architecture. So simply said, what's the current status for Longhorn? I use some sections here, some catalog here to summarize for what's the current status. Let's talk about first one, application interface. Actually, Longhorn provide a Longhorn manager, provide an API, RESTful API, and also we adapt the standard interface CSI plugin. And this is the major interface for user. But user, of course, we have a UI on top of Longhorn Manager to provide a simple interface for user. But at the end, Longhorn Manager and CSI plugin is the major interface for all the functionalities. And this is the API application interface. But next one is the microservice management. We try to apply the microservice pattern for our volume engine and replica design. Especially you can see the diagram I introduced before about the relationship between the engine and replica and how we manage the instance manager. So Longhorn Engine and Replicate, this is what we try to adopt the microservice patterns. And reactive storage service to provide a volume highly available capability for volumes, and on top of our volume engine and replica design. And also we have a self-healing and replica fault tolerance that try to rebuild the error replica in other places, other nodes. So this is the other way. This is one of way to provide reactive service for the storage. And also we have a different scheduling strategy based on disk, node, zone, and even selectors. And not just volumes operation, like I say, we also think further about disaster recovery. So this is quite a snapshot, revert, backup, restore, and even DR volume cross node. These kind of features we introduce. And volume functionality and disaster recovery, reactive storage, microservice. Not just that, we also think further to think about how to make Longhorn have advanced integration on different domain. So two of domain we are focused right now, and the Longhorn position on that is the virtualization volume support and edge support. And virtualization volume support, it can make sure Longhorn will be good candidate volume or storage provider for VM, a special solution like Harvester or Kuber. And Edge suppose because we claim we want to run anywhere, and because Longhorn with the low cost and best the performance for that. So we support ARM64. This is what we stand for. So this is current Longhorn. But how about the future? So future, if we talk about the same catalogs, so I would say from the application interface, we will introduce the CLI interface in the future. CLI interface is not just another interface. It means more possibility for the user to do the automation stuff, and will be help user to have a better management on for Longhorn. So microservice, for right now, the rewrite many actually, yeah, we do support, but it is the experimental feature for now. And the major feature we try to implement in near future is a rewrite many volume HA, highly available, to make sure the rewrite many can be work well with the one, not just one share manager. We had support HA model for that. And also reactive storage. We have a self-healing replica fault tolerance, but we want to do more and based on the more granular replica design based on sharding, and even have a cloning support for the volume itself to support different scenarios. And for disaster recovery, at the beginning, we focus on volume. Volume is our best unit, but we want to tackle different storage for application-driven backup and restore. So this kind of idea, we will try to make it introduced in the Longhorn support in near future. Based on application, distributed application, like a database or something, we can provide a suitable backup and restore based on our current Longhorn backup restore functionality. And for advanced integration, we will keep extending the support for the virtualization workload, like backing image management, VM cloning, and etc. And Edge, right now we support the ARM64, but looking forward, some of requests from the community, they want to see more architecture support, like ARM version 7 is all our under the consideration and in our roadmap to fulfill Longhorn can run anywhere. So this is a Longhorn feature. We talk about the current and future. So this is basically for my talk today. So since everyone's joined, and if you have any further question, feel free contact me or join our Slack channel. We have a CNCF channel, we have a Ranger channel. So just go to that, look for the Longhorn channel, and drop a message. If you encounter any issue or you have any request for Longhorn features, feel free to create a ticket on our GitHub repo. So we are very hope everyone join for Longhorn contribution. I think that's it. Thank you, everyone. Have a good day. Bye.